In this video, a couple of videos, we're going to talk about triangles, and one of the first things we're going to talk about are right triangles. Oh, great! The ones that are always correct. No, that was dumb. Right triangles are triangles that have one right angle. You can't have more than one right angle; it wouldn't be a triangle. But there's some corollaries, some additional properties if of triangles in general that come from right triangles, kind of. So first is the Pythagorean theorem. We remember this. If you have a right triangle, then the sum of the legs squared, so like you take each of the legs and you square it. If you add that together, that will equal the square of the hypotenuse. And it always has to be like that. The hypotenuse is what it equals. Yeah, so we can use that if we have right triangles. Anytime we have a right triangle. If we don't have a right triangle, you can't use this. There's something that happens though. If we don't have a right triangle, we kind of have something. Hopefully it makes sense, and I'm going to try and explain it here. So this angle I'm going to call capital C. Capital C, this angle right here. So that right angle. If capital C is obtuse, meaning it's greater than 90 degrees, then we have c squared being bigger than a squared plus b squared, right? Hopefully you can understand that, because if this is a wider angle than 90 degrees, then my sides b and a might be something like that. And then of course, c squared, this length is definitely longer than it was before. So we can say the side length c, so not angle c, that's different, is greater than a squared plus b squared. That's saying if you have an obtuse angle as one of the angles of a triangle. And then something similar to this is if you have an acute angle. So if this is smaller than 90 degrees, then of course B would be something like this, and maybe A something like this. Then of course this new side length is going to be smaller than the original C side length. So that's kind of the Pythagorean theorem, but it's a little bit more generalized, and you don't get exact values, you just know that, okay, well, it's either smaller or bigger. And so you have those two properties. Also, hopefully you remember this from geometry, the longest side is opposite the largest angle of the triangle, and vice versa with the smallest side is opposite the smallest angle. Hopefully that makes sense, because if you're opening some edges or some sides wider, then of course the side that's connecting to the other sides is going to be longer. So hopefully that makes sense. Or if it's smaller, then vice versa. Okay, hopefully that makes sense. We're moving on. The next thing I want to talk about are Pythagorean triples. And I'm going to say a Pythagorean triple is just a right triangle whose side lengths are all integers. So the first Pythagorean triple is a 3, 4, 5 right triangle. And if you check the Pythagorean theorem, 3 squared is 9 plus 4 squared is 16 equals, well, that's 25, right? 9 plus 16 is 25, and 5 squared is 25. So this is a Pythagorean triple. These are, if you know the Pythagorean theorem and you know how to use it really, really well, then you don't need to memorize these, but they're really quick if you do have them memorized. Some other Pythagorean triples, so 3, 4, 5 is a Pythagorean triple, 5, 12, and 13 is a Pythagorean triple, and you can test it out. 5 squared is 25, 12 squared is 144, 144 plus 25 is 169, and that's 13 squared. So we have 3, 4, 5, that's a common Pythagorean triple, 5, 12, 13, and also we got 8, 15, and 17. And those are the most common Pythagorean triples, but there are many more. You could keep going on forever, but those are the most common Pythagorean triples. So if you have those memorized, then you can look and see. Like if I showed you a triangle that has 15 and 17. Like this, then immediately, if you knew this was a Pythagorean triple, then you'd say, okay, without even using the Pythagorean theorem, you'd say, okay, well, this is 8, has to be. Or if you didn't have these memorized, then you would have to go and say, like, okay, 15 squared plus b squared equals 17 squared, and then have to actually solve it out, and you would get 8. So maybe something to keep in mind. Those are Pythagorean triples. We go into special right triangles. A lot of these things are shortcuts, really, that help you do things rather quickly. So that, like the Pythagorean triples, I guess you don't necessarily need to have them memorized, but it's a shortcut if you do have them memorized. So just take a look at those. I think 3, 4, 5, that's easy. That comes up a lot. 5, 12, 13, and 8. Okay, well, yeah. 6, 8, 10 is another one. I'm going to write that one down. That one comes up often. Those are some of the Pythagorean triples, and there's many more. Okay, what is a special right triangle? So, special right triangles, the two that are the two that we're going to talk about are the 45, 45, 90 triangles. That means you have a triangle whose, that's not a good drawing. There we go. So we have a triangle whose angles are 45, 45, and 90. These are important because you can figure out easily, like really quickly, what the side lengths are by this kind of ratio or proportion or whatever you want to call this. I mean, I should figure out the actual name. But this is how you can figure this out. It's so if you have one of the legs of the triangle, then you definitely have the other, because if it's an isosceles triangle. So if you have an equal angle here and here, or a congruent angle there and there, then the opposite side lengths are congruent. So if this is some number, then this is the same number. And all you have to do to find the hypotenuse, you could use the Pythagorean theorem to get this, but you could just multiply by the square root of 2. So as an example, if I told you that this was a 45, 45, 90 triangle, 45, 45, 90, and I said this is 3, then immediately what you could say is, all right, that has to be 3, and this has to be 3 times the square root of 2. Easy. Done. Like that's it. Or you can go about it in a different way. If I said, again, 45, 45, 90 triangle, and I told you that this was like, if I told you this was a 45, 45, 90 triangle, and this is the square root of 8, then first thing I would do is reduce this. Watch what happens. Square root of 8 is 4, square root of 4 times the square root of 2, right? Because that would be the square root of 8, but this is 2 root 2. So this I can reduce to 2 root 2, and then I know that this is 2 and this is 2, because that's the form of the 45, 45, 90 triangle. So you can figure out a bunch of stuff really quickly without having to do too much work, without having to reuse the Pythagorean theorem over and over again. And then in the next video, we're going to talk about 30, 60, 90 triangles. But the key thing for 45, 45, 90 triangles is both legs are congruent, and the hypotenuse is just the leg times the square root of 2. Sweet.